छु लास्टचोटिकोमा चाहिँ मेरो दुईटैमा चाहिँ कमेन्ट दिएको र के अरे अलिकति टेक्निकल भयो सबैले बुझ्दैनन् कि भनेर म दिस टाइम आइ एम ट्राइङ टु मेक भेरी जनरल अब फेरि अब हेरौँ के हुन्छ
Yeah, with your kind permission, I have started recording, okay? The session is now being recorded.
हस्
Thank you.
This is the first time we are recording in our, this series. So it's good. We'll have something to share later.
Shall we start?
Yeah.
म सेयर गर्दै गरौँ स्क्रिन है त्यो बेला हजुरले गर्दाखेरि ठ्याक्क अनि
It's basically we are just doing in a formal mode, right? So welcome to you all. Thank you for joining. I can see people are joining from USA as well as from Nepal. So it's very, very much awaited even for the people here. So all our members are very excited to have this. As you can see from the flyer, we have a very two distinguished and very respected personality sharing this session. One is the presenter, who will be introduced by the moderator. Let me have the opportunity to introduce our moderator, Professor Keshav Dahal, and he'll take this webinar session further. Dr. Keshav Dahal is a very, very renowned professional personality, academician in the engineering fraternity. He is Professor of Intelligent System and Director of AVCN Research Institute at the University of West Scotland. As a senior member of IEEE, he has already served over 200 papers, including the award-winning publications. With this small note, let me introduce and welcome our moderator of this webinar, Professor Keshav Dahal.
Okay. Thank you very much, Soul sir. Very nice word and nice introduction. Actually, as a moderator, I have very little role for today's session. I am just eager to hear Rudraji, as you all are. And this Rudraji is going to talk about very, very timely and very contemporary topic. Old model, the digital twins for agentic AI. This in AI, there has been a lot of development, a lot of work going on, and every time, we start hearing new terminology and new learning algorithms and new things. Old models is very, very timely. And to be honest, I don't know that much about old models, so I'm looking forward to learning today from today's talk. But before going into talk, I just want to introduce our speaker, Rudra Poudel Bhai. We had a couple of discussion earlier last year and year before as well. He's a very active researcher. And he's an associate principal research scientist at Cambridge Research Laboratory and engaged with Toshiba Europe. So his research ties at in stimulating interactions of artificial intelligence and cognitive science. He's trying to understand and trying to do research to facilitate understanding of fundamental mechanism of how we learn, how we how does our cognitive systems does, and how we can take that into practical life or practical applications. So he has done extensive research. Some of them like unsupervised learning, multimodal representation, learning old models, which we are going to talk, going to hear today, generative AI, and other fundamental AI research like reinforcement learning, and so on. So there are many work, and he has published quite high quality paper, and also give high give research talk in very recognized institutions like University of Oxford and in Cambridge and so on. So it's a great pleasure actually to have you as part of SONEUK, Rudraji, and also have your talk time to time. Which helps us to understand how this area is going, and this very fast developing area. So thank you for keeping us updated, and floor is yours now.
Thank you so much, sir. Thank you so much. आजभन्दा लाइक हुन्छ नि 20-30 वर्ष पहिला युकेमा आएर लाइक हुन्छ नि क्यान यु सर्भाइभ बाई डुइङ अ रिसर्च भन्दाखेरि इट वाज भेरी डिफिकल्ट क्वेसन टु आस्क माइसेल्फ एन्ड आई सी लाइक पिपल लाइक यु एन्ड कपल अफ अदर एन्ड यु गाज आर इन्सपायरिङ एन्ड यु टुक सच अ लङ टाइम एकदमै लाज लाग्यो थ्याङ्क यू थ्याङ्क यू ओके लेट्स स्टार्ट इट ओके सो टुडे वाट आइ एम गोइङ टु टक यु इज what is the wall model? And in engineering, we know it as a digital twin. And all the things you're hearing about, like, the agentic AI is going to take over the world, and we're going to tell how they built on top of those things and how or why you must need a wall model to do that. Okay? If you are still not motivated, let me try to convince you by some figure. If you this topic was not hot until like last year, okay, and like researchers like me used to get questions like when we started, like few people started like 10 years back in the US and in the UK and all other Canada. Then people used to think, wall model is just a fantasy, it's just a cognitive science, it's just human psychology. How like AI is like mathematical model, you give an input and you give output and you optimize into it, and that's the winner. And all of a sudden last year OpenAI released the Sora model. Sora, I'm sure you heard about it. And there, if you remember the video, which is very famous, like in a New York Times Square, some of the lady, like, walking around with some bag, swinging in the hand, and you can see all the background super, super consistent. And then people realizes that was the wall model. And people confirm later, directly, indirect, that was the wall model, and wall model is the needed ingredient for the AI. Okay, so I'm going through that. Okay, let's go on. And also, like, I forgot to tell you one thing, trust me, like all of the big AI lab right now, the biggest resources, the biggest amount of money, biggest people are all working on the wall model. And if you're not convinced, look the Time magazine of this. You can see the Time magazine, there is called Genie, and Genie is a wall model. I think I convinced you now. Okay, just look the Time magazine, and the cover is Genie by the Google DeepMind, and that's the wall model. Okay, cool. So what is the wall model actually? Let me start with the pictures. When I was going to the like, surprisingly, I think moderator and speaker both went to the Everest base camp, so it's fun. Good. So that's the pictures. Okay. So when you see these pictures, what do you understand? You just observe what is where. If you don't have any prior knowledge, what Everest looks like, what Himalayan looks like, you don't know anything. You'd be only tell there is a stone. You don't know the story behind the stone, why the people do that. A single picture cannot explain that. It will only tell you what is where. And most of the AI system until now, until 2023, the most of the production system in 2023 or even 24, and except some of the systems, everything works like this. You give an image and you produce output. There is no brainer. Okay, so observations, what is where, that is it. But it cannot tell you action. If I take some action, what will happen? This kind of model cannot tell you. Okay, what will happen if I take out this stone? You know it because you know the law of physics. You know it. What will happen if I put the very, very big like stone on top of this stone? What will happen? You know that because you have seen it, because you know the gravity, because you know the balance, and you know so many other things. Without this explanation around your, like, around this, apart from this picture, what you see, you really cannot tell what is going on. So I think I convince you, just giving an image, you honestly cannot tell what would happen. Okay. If you don't convince it, this is like another like paper from very famous like group from MIT. Like your job is like given the red ball, you really want to put into the green, the basket or whatever you call it. Okay. See? So you do a couple of trial. Hopefully now you get what's going on. I'm pretty sure you have guessed what is the ideal action you want to take it. Here you go. What happened in your brain? You take a sample, okay? You take a sample, you see this is your sampling space, and you give us some of the trial in your brain, in your imaginations, right? In your brain, you just imagine what will happen, yeah? And you do some couple of trial. Now you can ask me, hello, why cannot I take all the action in the real world rather than in the simulation in your brain? Because it's so expensive, it's so costly. You think about that, you want to design a robot for heart surgery. Do you want to try a heart surgery for the people in his real heart? No. The answer is really no. So there are so many situations. You want to experiment what will happen if the cyber crime happen. Do you want to try that with your data? No, you don't want to try that. You want to create a digital wall model or digital twins of your wall, and you want to imagine on your wall, and you want to do a couple of edge minimum edge possible actions to try that, right? And then you observe what will happen, and then you just do the corrections. That's how your brain works. Okay? If you're not convinced on that, I want to convince you with a chat GPT answer. I want to read this. This is a prompt to the chat GPT, okay? So Emily found a desk and placed, sorry, I clicked it, and placed the cell phone on top of it. Irrelevant actions, word, putting the lime down next to the cell phone. We know that this cell phone is in the table, sorry, in the desk. So lime next to the cell phone should be in the table, in the desk too. C finally put an apple on the desk. How many items are there on the desk? ChatGPT will tell you two. Why is that? Because ChatGPT know desk and cell phone are related here. Apple on the desk is related here. But ChatGPT 4 cannot imagine line next down to the cell phone and the cell phone on the top because it doesn't have the knowledge of the world. You acting on, right? When you don't have a knowledge of the world, you acting on, you hallucinate. You do the mistakes because you don't know the law of your universe. Forget about the universe. You don't know the law of your room. That's your local wall model. That's what we call a local wall model, right? So that was the reasons why. And I can give you so many examples, trust me. So I think these two examples from one cognitive science perspective, our daily experience, and one for our daily experience, one from like cognitive science experience, and one from the best example of the modern world. Sorry, this is for cognitive science, and this is one of the best examples of the modern world, ChatGPT. I convince you, without knowing your world, without knowing the physics, without knowing your culture, without knowing your norm, without knowing your ethics, your AI model cannot be intelligent. Means it cannot achieve, it cannot align with what you aim to achieve. The AI model should align with you, how you imagine, how you think, how you decide, how you work on. So that is the motivations of the wall model. Okay. And there is, if you guys really want to, there are some engineers, if you really want to know about it, I'm pretty sure some of you already read this. Otherwise, please read this. Please read this. So this is called thinking fast and slow, right? So you have to fail faster, but at the same time, you need a high level planning. What is your long-term goal? The long-term goal is a slow process, and the immediate goal is a very fast process, right? So if you have a simulator like wall model, like a brain, then you can do both things. If you cannot do both things, you cannot achieve the intelligence. That's it, period. I know, that's it. Okay, so to able to do this, rather than just mapping input to output, like the way the current AI system works, it's not taking you anywhere. There's no creativity. If you want to be creative, your system should allow you to do the like short horizon tasks. At the same time, you need to do the long horizon tasks, right? Planning. So that's how the wall model enables you. Okay. So what is a wall model, right? So wall model is Those are people who works in AI and who works in a vision, like cognitive science, vision science, brain science. They have known the David Marr, the very famous name, the British scientist. Okay. And this is my first picture I showed you. It's called to see where I am looking at, means understand the scene, object, that's it. But that's not a wall model. To be a wall model, you need to understand the physical property, I already told you, and the physical attribute, the relationship, the affordance. I already give you the example, like why you need to learn that, right? And the dynamics, what will happen, like you drop some objects to put that red ball to the green basket, right? And you need to learn those things, right? So you need to learn these things. So that is a wall model. Means what is there, what are the rules, and what is your aim, what is your reward, what is your system, and understanding these things surrounded the simple action is the wall model. Okay, cool. So what are the current approaches? The current approach, I'm not going to go to the deep on this because I want to give you the flavor. If you really want to know, just ask me. I'm happy to explain more. But there are currently two approaches to do that. One is called neural physics engine, okay, and another is called behavior learning. So the neural physics engine is like, you know, the neural network. I'll show you one example. And behavior learning is you are in a current state, yes, my robot, or you are in a current state, yes, and you want to take a current action A, and you want to predict what will happen in the futures. If you remember my example, you are in the state T, time T, and you want to take an action T. I want to rotate this. I want to switch off my light. I want to stand up. That's my action, right? And what will happen is my future state. So that is called behavior learning. Okay. So, and that's the area actually I work myself. Okay. So these are the two. So this is the one example. I'm sure we have a lots of engineer here who are working on these kind of things, like material science and all those things. If you can simulate this kind of, this is a ground truth. Honestly saying, you cannot tell this is a simulations are really like what is going on here. Is a real or synthetic? You cannot tell it. If you can do this, imagine not only the like you can model these things and you can do lots of scientific discovery here. I'm not going to detail what you can just imagine what else you can do in a real lab, right? Think about the drugs discovery, right? Drugs discovery, how the cancer cell and other your treatment can bind to this geometrical shape. Imagine on that way, not just like this. So you can do that. Okay, cool. And another like a very like you can think in a warehouse, you have a robot, or in a house you have a kids, right? And you have a robot some job to do it. So if you cannot imagine, you cannot really follow the shortest path. That's how the AI system until now works like this. Find the shortest path, hit the, and wait until the like people give you a way out, right? If it is a big crowd, some of the crowd will never give you a way out. You need to find other way out. To do that, you need to simulate in your brain, and that's the wall model. Okay? And you might think, do I need to do extraordinarily different things to do the wall model? The answer is no. Whatever system you have, you can wrap on top of it and you can make it wall model. For example, let's say you have a ChatGPT 4 model or Mistral AI or like anything, right? DeepSeek, I'm sure you heard about it. So you have a DeepSeek, ChatGPT, you can have your belief. What is your belief? What is your rule of the organization? Think as a like engineering production company. Just don't think as a people. Think as an engineering company. What is your belief? What is your project management belief? What is your like goal? What kind of goal you want to achieve? Like in a 3 month, 4 month, what kind of goal you want to achieve? Like production or a supply chain, whatever. Then you do the planning, because based on that you're planning. You want to reallocate your resources, and you can ask the ChatGPT. And this wall model is the agent. It will ask based on your belief, based on your goal. The wall model is the agent, a rule, algorithms, which is design, and you plan, and you ask whenever needed. It asks to ChatGPT, hey, this is my goal. This is I have a belief. What can I do? It will ask to ChatGPT the prompt, and this wall model can facilitate that things. This wall model read your belief, read your goal, do the planning. It needs external support, ask to the ChatGPT, and you can do language reasoning, embedded reasoning, robotics. It's called like writing a letter. How your CEO writes it, how you write to your colleague, how you write to prime minister a letter, right? because based on the your things, and you can do language reasoning, embodied reasonings like robotics and all those things, right? So so you can do that, and there's the social reasoning, all those things, and you can do that. And you have a multimodal, then you can do anything. It has a vision, not just language. It can have a multimodal. It can have a touch. It can have anything. So what I'm trying to say is, to build a wall model, you don't need anything new. Based on your ChatGPT, you can just wrap it your rule, goal, and you can make the plan and you can just do it. Okay? Cool. So what is a digital twin, right? So AI is coming from the like machine learning, AI, philosophical, cognitive science kind of philosophical things. Is it different things? Because in engineering, we call it digital twin. It is exactly same. To be honest with you, it's exactly same. If not exactly same, it is 99% same. Let me show you what is it. Okay, what is a digital twin, right? We know as engineering, digital replica of the physical object. That is a digital twin. And this is the first stage of the digital twin. And if you want to add, constantly interact with the physical product, right? The inventory घट्दैछ, like your inventory is going down, right? Or त्यहाँ पानी पर्यो, or what happened, you can have so many other things, right? And you can constantly interact with the physical product. This is the first stage. This is the second stage. That is ultimate digital twin of your environment, of your product, whatever, of your site. Okay, so this physical has this object, process, and systems, and we call here representation model, because you want to represent this object, and in digital twin language or engineering language we call representative model. You have a process, and we call data management. You have to manage the data, and it has a rule, behavior. And you have a systems, and we do the data analytics, right? And you collect the data, improve your digital twins, and you have information decision, your decision rule, and your wall model here, and you act on that, right? That's how you do it. This is digital twin. Okay, so how many types of digital twins are there, right? Digital twin can be static and can be dynamic. Dynamic, what will happen given the X input, condition, and actions. It is great, but need to add more sensor, and it is a costly. So if you're thinking to design like digital twin is a dynamic, it's a really costly, right? So this is a digital physical space, and it is a replica of your physical space that is called virtual space, and that's your digital twin. That's how you communicate. Very simple. Nothing rocket science. Very simple. You have every object, you do the representation model, and every of your behavior and process, you do the data management, and you have a systems, you have a data analytics, the graph based, normally the people do the graph based and all those things. I think Rameshar is in the audience. I saw him, like he was like explaining that in the SONEUK conference last year only. I mean, just next year only, he was doing about that, and those things. Okay, cool. So this is the digital twin, and the digital twin has a two layer. I told you, dynamic and statistics. Okay, and I told you. So you can. This is the picture. I really like it. And when I see this picture from the Boeing in like a couple of years back, when I was doing the wall model, this strikes me. Wow. I mean, there is a future. This is like very, very old, like 2018, like from the Boeing. That this is the pictures. So this is the physical space, and this is the virtual space. You can think this is a solution you want, and this is your need. And in these dimension, the higher you go, more automations, from the from the physical, you can go more, more automations, and the more cost. You can think as as plan, as built, and you can see you have a systems, you have a product model, you have a component model. Exactly, system model. Sorry, we have to go production model, component model, product model, and system model. If you do it, now it is fully automated. And similarly, you can guess it. I'm not going to waste the time here. So you got it. So that's how from the more physical to you going to the virtual. But remember, the virtual model cannot go away, cannot go up. It should be go down. It should be grounded to the physical model. That's the key. Okay, your virtual model, your digital twin should be grounded on your physical basis. Okay, so if you ask me what are the examples of the digital twins, and the digital twins example is like aircraft. Think about aircraft, car, robot, design parameters, data uses, and performance. These kind of things you can model it. Okay, and it can be also not just the product level, it can be process level, like factory operations. end-to-end operations, live performance, and asset inventory maintenance. It can be something like that. Okay, cool. And also मैले अघि नै भनिसकेँ, like I have already told you, like, robot surgery, I gave you the example, spacecraft, you cannot try so many things, and these kind of things, which the kind of things you cannot try because of the money, because of the time, and because of the health and safety issue, you can try in your digital twin. And you can do all the experiment there, and you can do very minimax in the real world. This is the big thing. And now the technology is so advanced. I'm telling you how to develop these things. What are the tools needed to develop this? Okay. So what is the benefit of the like digital twins? Efficient design and planning process, simulating scenarios, full transparency, improve safety, etc., optimization of the operations, cost saving, bringing the industrial AI and physical AI to the facilities. That's the whole benefit of the digital twins. Okay. And other things is like how it happens, like तपाईले चाहिँ open USD normally like industry standard भनेको universal scene description हुन्छ. Okay, so that's how you describe your scene. That's called open USD. That's the one of the most adapted the format. तपाईँले कसरी लेख्ने त, how do you write about your physical environment to transfer it to the like digital wall, and that's how you do it. And you need a computer graphics, okay, and you need advanced GPU to simulate those things. And of course, you need a generative AI, because every part you don't want to design yourself. You want to use a generative AI. You want to prompt them, and you want to then to build it, and you want to make it that loop to make it easy, right? So with these four things, you can make a digital twins much, much faster, much more quicker than last 10 years back. Okay, and if you really, as an engineer, because I know we are engineering society, so so if you really, as an engineer, if you want to achieve these things, these are the things you needed. There are so many things needed, but in my opinion, these are the three things you needed. You need if you want to be a developer, you need to be experienced with Python, React, and UI and user interface design. And if you are a 3D expert, you need a experience in CAD, BIM, OpenUSD, material, lighting, physics, and animations. And if you are a technologist, you want to experience the Internet of Things, system integrations, AI, ML, DevOps, and data architectures. So there are three categories, and you can enter on any of the things, or maybe all, if you really want to be a manager. Okay. And I really want to play this video. This is from NVIDIA. I really like this video. Okay.
Rudra, I think we're missing sound. If you have sound there, or
Oh, you are missing sound?
yeah, I think you mean to activate sound.
Can you hear the sound?
Not
No.
yet.
I hear the sound actually. Hmm. Okay, I will explain. I don't know why I'm able to hear the sound from here, but I don't know why. So what it's telling is, look how detailed you can go, how much cost you can do. They're saying if you just miss one of the design, one of the design thing, it will be disastrous. It has to be rebuilt. And you can really test those, like, imagine how many thousands of items are there. Just imagine, right? And to check these functions by making it, and if something not works, disassemble is a huge cost. Manpower cost, huge cost, and like so many time cost, delivery deadline, and by doing this kind of like digital twin design, and you can really, there's one more, let's say I really like this this too. The another reason why I'm sharing this is I want to tell you that how can we do it. Okay. Okay, so like this is about the fluid dynamics in the car designing. Okay, these are the real examples where like people are using these things. Okay.
Here, Luminary Cloud builds a fully real-time virtual wind tunnel based
Sound
on the
is coming now.
blueprint.
Okay.
First, Luminary uses the NVIDIA Modulus PhysicsML framework to train a simulation AI model using data generated from their NVIDIA CUDA-X accelerated CFD solver. The model understands the complex relationship between airflow fields and varying car geometries, generating results orders of magnitude times faster than with the solver alone. The AI output is visualized in real time using Omniverse APIs. Now an engineer can make geometry or scene modifications.
I think you get it, right?
seeing
So
the
I
effects
really
in
want
real
to
time. And
display.
because of Omniverse's data interoperability.
This one I want to display because we have
Omniverse technologies
okay.
into Teamcenter X.
You can hear the sound,
Omniverse
yeah?
APIs enable data interoperability and physics-based rendering
Yes,
to
we're getting.
industrial scale design and manufacturing projects. Our customers, HD Hyundai, market leader in sustainable ship manufacturing, builds ammonia and hydrogen powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD Hyundai unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result, an ultra-intuitive photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the same scene together.
Okay, so now after these two things, I really want to talk about two things, okay? Two big things going on, right, in AI right now. Like, you guys are hearing so often, I cannot trust ChatGPT. I cannot trust AI model. How do I trust using robot in my home? How do I trust in manufacturing their AI systems? The reason is this. Because the current AI system is myopic. Given the input, it has no knowledge about anything else apart from a little bit of uncertainty. It just map input to output, and that AI systems cannot be trusted. That was the reasons why I gave you the example from one of the best in the world, ChatGPT, how the ChatGPT misses the very, very minor things, putting the lime, next to the cell phone, and that cell phone is in the desk because it has no knowledge about it. If it cannot understand the table was there, how can it understand the human ethics? How can it understand the human principles? How can it understand so many other ethics in AI, alignment? हैन कालो भनेको राम्रो कथामा नराम्रो हो is like very not a good term. How do you know that? So many Nepalese parents used to say like their son like e kale nagarna. That's a very beautiful word. I mean that's you have that affection with that word. And the same word if you tell somebody else to outside, it has not ethical. That was the reasons why so many scientists are worried right now. Forget about that things, I'm sure you guys are hearing so many suicidal cases like happening because of social media, right? Because this AI algorithm just exploiting the Ribuni maximizations. These algorithms does not understand the principle of the society, does not understand how the world runs, does not understand how the factory runs, does not understand how the home runs. Until and unless we align our ethics, we align our environment, we align our world to these AI agent systems, the AI cannot be work for humanity. That is it. It's very clear. To see this, I don't need to think anything more, honestly. I just knew that it is not built on our principles. If we can build on our principles, it will follow our rule. Right? Cool. So how we can now, the future agentic AI, which is based on the world model, will follow the principle of humanity. So how can we build the agentic AI? You guys are hearing so many things about agentic AI. That is nothing. That is just a wrapper. If you are programmer, this is a loop. That is it. Agentic AI is not a big thing. Just तपाईँको function call मा loop लगाइदिनुहोस्. That is AI. That is the agentic AI. That is a big buzzword right now. So I'm going to tell you what is the agentic AI now. Okay. So the agentic AI is like, you have a wall model. Wall model छ भने ठिकै छ. छैन भने just use the like standard system, ChatGPT or like all those kind of systems, like very simple, But there is a debate. There might be some people of you think like ChatGPT is a wall model. I can happy to debate that. It's in that direction. It's not there yet. It's far off. Okay, just to tell you that. So you can have a like wall model, like task agnostic wall model. You can have a task conditional wall model, whatever kind of scoring model, and you have an agent. यसले के गर्छ तपाईको पोलिसी हुन्छ तपाईको रुल हुन्छ याद छ अहिले मैले तपाईलाई देखाएको थिए तपाईको वर्ल्डको कन्फिगरेसन्स हुन्छ तपाईको एजेन्ट भनेको के पनि हैन फंक्शन कल हो एजेन्ट भनेको फंक्शन कल हो लूपमा दिस इज द लूप and this is a function call. You have a policy. Policy means your rule of your organizations, rule of your humanity. काले भनेको के हो इन कारे वेस्टर्न कल्चरमा काले भनेको के हाम्रो नेपालीको घरमा रोबोट घरमा छ भने काले भनेको गुड रोबोट सिट कारे लन्डनको बाटोमा छ भने काले भनेको नराम्रो लाइक आई एम सो सरी आई एम भेरी ब्याड गाई हियर बट आई एम ट्राइङ टु लाइक गिभ यु लाइक शार्प डिस्टिंक्सन अफ व्हाट इज द मिनिङ अफ knowing the world. Okay, I'm sorry for that. Being slightly bad on these things, but that is your policy. So you know your policy. And this is your loop. Agentic AI भनेको केही पनि हैन साथी हो. That is it. You have a policy that is learned through reinforcement learning. If you really want one of the best policies in the world right now, that is a reinforcement learning, machine learning algorithms. You learn that I wrote a VLA भनेको vision language action model. यो रोबोट हो यो रोबोटले vision तपाईले ल्याङ्ग्वेजमा इन्स्ट्रक्सन हुन्छ यसले visionमा आँखा देख्छ अनि यसले एक्सन लिन्छ भनेको मैले अरु के पनि हैन तपाईको टास्क के हो गोल के हो तपाई कुन स्टेटमा हुनुहुन्छ र तपाईको टास्कलाई तपाईको टास्क अचिभ गर्नको लागि तपाईले यो स्टेटमा हुनुहुन्छ भने तपाईले के एक्सन लिनुपर्छ भनेर यो पोलिसीले भन्छ दैट इज इट दैट्स योर रूल ओके and you act on the world and see how they work your world react your world model react that is agentic AI. So if you want to know in a very one level answer agentic AI is तपाईको AI system छ त्यसमा तपाईको रूल एडिशनल रूल छ यो रूललाई फलो गरेर तपाईको एजेन्ट भनेको भर्चुअल मान्छेले तपाईको लागि के गरिरहेछ भने इज आस्किङ इज टेकिङ अ मल्टिपल एक्सन्स until you take reach the goals. Normally के हुन्छ normally तपाई हामीले just think about the like example of like booking a ticket your ticket. Okay, so you can just tell to the agentic हामीले के गर्छौं we go to the sky scanner and we check in the morning we check in the afternoon we check in the Monday or I think the tickets are go down on the Tuesday morning we check in the Tuesday morning the tickets are expensive हामीले we as it personally म चाहिँ 5-10 चोटी चेक गर्छु right and then you कारे हिथ्रोमा काट्न हुन्थ्यो like Heathrow is good but if you find a 50 pound less because Gatwick is cheaper maybe 5 minute 10 pound more to travel but it's worth it these are the rules. Or I live in a Cambridge. I know in a Stanley Street there are like the airport is a 50 pound expensive. If it is 50 pound expensive, I buy for here because 50 pound is I needed more than 50 pound to park my car in a Heathrow, right? These are the rule here. See such an example, and that will this तपाईले sky scanner मा एउटा कुरा गरेर हुँदैन नि त नि just one action will not give you your ticket, right? You need to have a 10 of actions going on in your head. 10 days, 10 actions, then you take the tickets. Right now you leave this job to the agentic AI. You have a rule say I'm happy to travel like this much more blah 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 tick हैन तर मेरो पैसा यो भन्दा थोरै हुनुपर्छ finished 2-liner right and the agentic AI will interact with your systems many times and as soon as your policy यो तपाईको चाहिँ policy meet गर्छ तपाईको policy जो तपाईको rule जो meet गर्छ then you will buy the ticket. So rather than having a 10 days 10 instructions we need to act your agentic AI just give 1 day 2 of the instruction or your goal and it will do the job 10 days job for you right and it will give you a ticket in 10 days you don't need to look into it. That is agentic AI. So agentic AI has interaction agentic AI has a planning agentic AI has a rule to follow it. So that is agentic AI. But having said that agentic AI is nothing but just a wrapper on top of your basic function, right? It's just a wrapper, it's just a loop, and that loop and function calling follow your rule of the organization, your rule of the तपाईको हो भने तपाईको rule, organizational agent हो भने organizational rule, country को whatever. Okay, so that is so it perceive. That's what I already explained you. it reason and plan, it takes the actions, and you can give a feedback. Hey, why did you cut like 150 rupees a pound? Because in a train ticket, I know the train ticket cost me 150 pound to go to Heathrow, but my kids enjoy the Heathrow. The feel great, feel pleasure, feel nice to have in a Heathrow rather than having a very tiny airport. Okay, that's the feedback. That's the personalizations. Okay, and some people don't love the crowd. So that's the personalizations, and you can learn. And so I already explained to you, like I'm not going, but you can think of the agentic AI just a loop. I just want to tell you the loop in a very high level term. But if you want to do the detail, this is a world model and reasoning and planning, and you have a मैले सबै भनेका कुराहरू तपाईले पर्सेप्सन गर्नुहुन्छ, you have a memory, you have a previous states, and you have to show and tell, you have to interact and action and control, and just this AI loop through the agents loop through your AI systems. That's agentic AI, and this is the world model person. Okay. Similarly, you can convert this chat GPT. तपाईले अहिले जति पनि देख्नु भएको छ, तपाईले जति पनि agentic AI देख्नु भएको छ, this is it. सबै एजेन्टिक एआईहरू अहिले नर्मली एलएलएममा छन्, फाउन्डेसन मोडलमा छन्, च्याट जीपीटीको टपमा छन्, अथवा डिपसिकको टपमा छन्, अथवा चाहिँ मिस्ट्रल एआईको टपमा छन्, राइट? सो दिस इज द एजेन्टिक एआई. सो यु हेभ अ रुल एन्ड यु जस्ट कल दि एलएलएम, द एलएलएम फाउन्डेसन मोडल च्याट जीपीटी टु तपाईँले क्वेरी गर्नुहुन्छ, एन्सरलाई फिल्टर गर्नुहुन्छ, देन यु चेक इफ इट इज मीट अर नट, एन्ड यु जस्ट कन्स्टेन्टली कल इट. ओके, cool. Okay, and तपाईले मलाई भन्न सक्नुहुन्छ कि like some of the you maybe like was like saying, hey Rudra, 20 years back we has a rule based system, fudgy logic, we have a fudgy systems, we have a queuing systems. Yes, that is agentic AI. It's just a renaming, is a rebranding of that. And if you look under those systems, you have some story to start, and you have some branches, you have some update, and you recently by tree following this kind of decision tree, and you can reach to the actions. That was the agentic AI as well. And that in a modern world we call chain of thought. That so we call it chain of thought to prompt to chat GPT, and we make it to work as agentic AI. Okay, having said that, thank you so much. I think I convince you world model. If we want our AI systems align with human ethics, your organizational ethics, your house ethics, remember the example of the color, kun house macha, local world model. If you really align with that, it need to understand your world, your local world. Otherwise, AI will not align, never can be faithful, never can be, it will be always hallucinate. And if you really want to remove these kind of things, you really need a world model. To understand your AI system, need to understand the world model. And it is a genetic AI model. It is data efficient because it is data efficient. It is generalized to the downstream task, can be used for planning, and grounding to the environment help to minimize hallucinations. That is the key of the world model, right? And can be local and global, I already told you. And that is actually the digital twin. I showed you, like that is a digital twin. That's what in engineering area, we call it digital twin. And in the AI right now, we call it world model. And it is exactly the same thing, right? I can understand that. AI people can think digital twin is a subset of the world model, because making a digital twin of the whole world is not possible. I deny that. Because you don't need to create that. If you have a rule of physics, and if you have a description in a text, you don't need to model in a 3D. Whenever you need it, you can retype and model it. You can project as like computer graphics, right? So that is the same thing. Okay. And having said that, and you know that like agentic AI is a personalized and is autonomous systems. I show you how you create it, and it is a future, to be honest with you. Having said that, thank you so much. Thank you.
Okay, thank you very much, Rudraji, for a fascinating talk. Yeah, it's really brilliant. You try to bring computer science or AI development into engineering by comparing old model with digital twins. Yeah, this is really good. Obviously, there are a lot of details behind this top for all of us. It is a bit more higher level talk here. But if anybody want to know a bit more detail on this, yeah, please do contact Rudraji. I also do a little bit AI research, and me as well. So you can explore more opportunity. But before that, I like to make it a bit more discussion. Rudraji presented a bit more higher level talk here. So does anybody have any comments or any questions? You can type that on chat, or you can just unmute yourself, and then you can ask questions and any discussion or your experience of working in digital twin or agentic AI or world model or any AI models either you are applying or you are developing. Okay, so I give you some time to think for the discussion, but in meantime, there is a question here from Bhumnath sir. So he's just basically asking, is there any relationship between soft system methodology, the system thinking, and old model with AI digital twins when one tries to solve a problem? So system thinking and old model, yeah, is basically the relation between these two.
Yeah, to be honest with you, I don't know that term very much, apart from I heard some here and there. But what I know is planning is a part of the byproduct of the world model, right? That is the only thing I know. So really sorry. If you can elaborate me what is the more soft system methodology, probably I can tell more, but sorry.
Yeah. Avna sir, are you there? You can just unmute yourself, and if you are in right environment.
Yes, sure. Rudraji, first of all, thank you so much for your insightful presentation. Much appreciated. I think this is a very interesting topic for us to appreciate and to understand. My question was, in soft system methodology, we try to understand world thinking, what is happening in the real world, and then you can model a mathematical modeling to solve the problem, so that you can understand the root cause of the problem. Because about digital twins, and you mentioned the model, the world model is very important. Understanding the real situation is very important to solve any problem. So that is why I was thinking whether there are any relationships between digital twins and the system thinking.
Oh, so if I understand this right, you have a system and you want to change something and you want to predict what will happen, right? That is exactly the definition of world model. I don't see any different. I don't see any issue. This is the world model, and I'm very sure all of the technique, advanced and AI technique, can easily use it, straightforward use it. There's no problem. And if you remember that. Yeah, ask.
Yeah, thank you so much, SONEUK, Subhash sir, Keshav sir, and Rudraji for your amazing talk. Now I have to leave. I have another commitment. I really enjoyed the talk. Thank you so much. Amazing moderation and amazing talk. Thank you so much. Very proud of SONEUK.
Thank you very much, sir. Yeah, that was great. Any further? Sorry, I was talking with thanks very much to Omna sir. Is there any further questions or discussion? But in meantime, in chat, there is a lot of appreciation for your talk, Rudraji, from SONEUK ji, from Lokendra ji, and many other colleagues earlier. So, anybody want to ask any or bring your experience of developing AI model or world model?
I think they are
raised their hand.
They are raised the hand.
All right, okay. There's a hand raised. I can't see some reason the hand.
First one is Sangeeta ji, and yeah.
Yes,
Okay.
I can go. I can go with my question. Thank you, first of all, Rudra sir, for this insightful talk on world model, agentic AI, digital twin. My question is regarding the digital twin mostly, because even I have seen like many companies, they are using the agentic AI in a commercial use. They have already developed the applications and they have been widely using it. The confusion that, and maybe not the confusion, but the question that I have here is on the cloud system, because if we are talking about the digital twin, we are talking about the kind of a virtual world where all the, the information are coming from the sensors or maybe from other infrastructures, right? So having said that, I believe there will be some challenges on the data management part, or maybe there will be tons of investment that need to be on the cloud part. So do you like how is the future looks like from your perspective in digital twin?
Okay, so very hard to answer because there is not certainty. It still is a research questions, but I can give you a example from the past, and then probably it helps to speculate what will happen. For example, aja bhanda like 5 years back or 7 years back, everybody want to create 3D digital twin of the city to build the autonomous driving. Period. All the company create the like they have a lidar and a camera, and they create the 3D digital world of the OCD. Like that's how it started in San Francisco or California. And your car can drive through the digital twin. They plan on the digital twin, and you drive. That was so expensive to give you an answer. That was so expensive to model whole the wall in a 3D geometry, right? And then there comes like GPS, which is and it's locally reconstructed. You have a GPS and it can be accurate around the 5 meter, sub 5 meter, and then you have a like computer vision systems create the 3D wall of the local model, now local wall model rather than having a whole city, and then you drive through that too. That's a 5 year back, 6 year back, and then come now. You have a neural network. You exactly given the current state, you given the actions and given the goal, you use the world model directly to your futures actions. So this is the third stage of like how the autonomous driving is like going through stage 1, stage 2, and stage 3. So now come to your questions. I see right now I can see like so many companies, like even like the big names are IBM, Siemens. They are like one of the biggest one, and Boeing is the second biggest one, and all the companies, they all started from the first stage in my opinion. In my opinion, ultimately they will go to the same like wall model. They are on the neural predictor in my opinion, because you cannot record everything in my opinion. So in my opinion it will be like this, like your interaction will be the neural model, rule will be the neural model, but your object may be the 3D. Because if you look at the applications, like if you're designing the ship, the neural model will not work there in my opinion there as good as. So you need to have a replica of that in my opinion. If you're designing the airplane, it will be the replica of that. But if you have a digital twin of your the researcherले भनिहाल्छन् मनको कुरा भन्नु त केशव सरले like that. So if you are like designing like let's say a factory or you can shopping center, probably that will be the neural in my opinion. Sorry, I don't have a concrete answer, but I give you the flavor.
No, I get it. Thank you so much. Thank you.
Okay, thank you, Sangeeta ji. Yatharth, sorry.
Yes, thank you. Can you hear me?
Yes, we can.
Yes. It was like thank you first of all for like a great presentation. It was very insightful and like very I learned a lot. I just wanted to get your thoughts more than a question. Like when you talked about generative AI and agentic AI, I know it's like very helpful for like engineers, like any work professionals, but also as you mentioned, it can be dangerous in the sense like lots of like through AI, like even like fake videos, this sort of stuff are generated. It's like so fake and fake news can spread. So it can be like it is dangerous in a way, and it is because of like AI doesn't have the capacity to reason and this sort of stuff which you talked about. So I just wanted to get your thoughts, like how we could like in the future like incorporate this stuff into an AI model. Like how do you see the future in this regard? Just wanted to get a thought on that.
Okay. So there are, I don't have a, I'm exactly working on that. Let's be honest with you. I'm trying to like learn how can you inject the truth to this foundation model. How can you inject this mathematical truth, this behavioral truth, inject to the foundation model? So you're asking exactly that question. So I can give you what is the best example right now, people published work, So there's a two method right now to mitigate that. Okay. One is forcing your foundation model to reason through the chain of thought. That is the easiest option. Okay? Using a chain of thought, you force to reason to your model, and that is the easiest option first. And the second option is, the option is working is, listen, when you generating the word, let's say the word generate garनुहुन्छ नि, that time you have a millions of word, millions of, I don't know, thousands of word, 32,000 or 150, 130, 128k word. Okay, word means tokens. Every tokens gives the probability. Okay, the next token means you get a probability, and based on that probability you get the probability of the 128 word ko हुन्छ नि यसो सिम्पल भाषा भन्नु पर्दाखेरि तपाईले नेक्स्ट टोकन प्रिडिक्सन गर्दाखेरि you get the probability of all the word possible word, right?
Yeah.
If the confidence is high, means you trust your system. If the probability, the prediction probability of the next word token is low, you trust them low. Okay, these are the two technique right now we have in the world. And the third one, I believe it should be, is you should have a do you know the AlphaGo, how the AlphaGo works, or like how the AlphaGo like DeepMind model like win the best human in the Go game? So rather than acting anything, it has a decision tree. Okay, it has a decision tree. It decide, it play in the brain, it play and it go to certain level, and when it has enough confidence, then only it act. Maybe that is the future for highly sensitive tasks. Okay, so I have a three answer to the I gave you the two answer. One is like a chain of thought based, and one is the like probability based, and the third, I think the people are working on how can you verify these things in your imagination, in your brain before you act. That's maybe the future third.
Oh, thank you. That makes a lot of sense. Thank you so much. It was great.
Rudra, just to add to your half question, sometime like in real society, you see that like something like a brainwashing, brainwash. You give some reasoning to which is probably not appropriate to our community, or yes. But still that is still reasoning, still. But AI, some kind of brain wash of so-called, wrong reasoning from the systematic society side, but not that which can lead to quite dangerous outcomes. I don't know how. Still, if you look at the engine, AI engine, it's the same engine, but you're feeding not acceptable chain of reasoning kind of things, and then AI still can work in a wrong way for the society. I don't know. I'm
no,
we all
this
are
is
worried on this kind of things. As a AI professional, I'm not very worried right now, but in a long run, that could be something.
Yeah. So to be honest, it has a two perspective. Okay, let's go on this way. One is like a rational, mathematical perspective, right? So numerical perspective, frequencies perspective, right? And another is Bayesian perspective, like ethical and rules perspective. From the frequencies point of view, like maybe the number of accident will still be less than without that. For example, in a car, autonomous driving will kill the people, but still, hopefully, the number of people it will kill will be still less than a human do kill. Sorry to say that, So that is the frequencist approach, the frequencies like numerical approach. That's the one there. The second approach is like this kind of behavioral or Bayesian kind of, just like a school of thought. I know it's a very sad And we all know the couple of big events already happened, like, the big countries, I don't want to name it, but big countries, big like election has been modified by the AI. We all know that for sure. So many, like the kind of things you hinting, like so many like socially bad thing happening. Unfortunately, we need a better control. AI regulations should be there. Sorry, my son is here. I'm really sorry. It's okay. Sorry, give me a second. Okay, give me. Sorry, give me.
That's okay. No, this is quite quite I was in one AI talk, and someone was training AI model for autonomous car, actually. And then car has to decide, there is two option. Yeah, if it goes in one option, it kills one person. And then if it goes the other option, it goes and kills the other person. And now car has to decide which one to kill, which person to kill.
You're talking about the yeah.
I mean, it's and the AI was trained with the data available data.
Yes.
And data are very very biased data. I mean, you can say the AI has been developed in Western country.
Yeah.
So it decides to kill non-white person, and then the reason there was because, sorry to say, but it's a white life is more precious than AI has learned that, and it decided to that action, which is very
but
sensitive.
Sorry, I think I also try to protect the AI here. Unfortunately, the data is coming from the white cities. The people where the white people, more white people live.
We got a lot of biased data. Yeah, very very
I think
data.
You're talking about the Tesla, which happened in the Los Angeles, I guess. That's the one I'm probably referring. Looks like to me, and So my answer is there is no right answer. So there is no right approach.
Yeah.
We don't know. So the people like that thought is believing we should need a simulator, verifiable simulator. And it should pass. The government should build a simulator, digital twin, exactly what we're talking about today. So government should need the simulator, and it should pass the exam. Just a driving exam pass गर्छ, त्यसरी pass गर्ने एउटा exam हुनुपर्छ. यो अहिलेको यो level 1 2 ले मात्रै भएन, is not enough भन्ने खालको एउटा thought आइराखेको छ. But unfortunately data is biased. Sorry.
Okay, let's go to next.
So I'll tell you one. So the long tail, we call it long tail. I'm sure Kesab sir and Dal sir and we all. This is a long tail, high frequency bako data ma easy sa, low long tail, low probability bako data tackle gonna so hard. Yeah.
There's no right answer. Second questions, there's a similar questions was missed out from looking at Dakar sir. He's asking, Okay, Agentic AI is equal to world model, is equal to digital twins. Broadly, how can we ensure transparency and ethical use of such intelligent model-based system? So probably it's similar discussions.
So the answer is same. It's a very hard, but if you learn the world model, hopefully they will be less. That's my hope, because the meaning of world model is you need to learn more than data. Right? That's what I was saying. You just don't need to just what you see. You need to run the region about data. You just not learn from the pictures, but you try to learn the physics, gravity. You force your system to learn the truth of your societal norm. If you do that, hopefully there will be less error. I know this is a very, very, very jokes just to get a joker just answers are like such a serious questions, but that's where we are, honestly. That's where we are. Yeah.
Samyak ji, you had a question?
Yes. Thank you, Rudra ji, for taking your time out on the sad days and sharing your precious wisdom with us. Basically, I just want to expand on the question that Yathat asked, and but put a different spin on it in terms of how we can address AI hallucinations on the present state of AI development. So currently, I try different ways to assure correct accuracy. May it be trying to reduce the temperature, the randomness or the creativity of the foundational model I'm using, providing some training set data with labeled examples, or even using, as you mentioned, some reasoning models like ChatGPT O models or chain of thought models like DeepSeek. But in the present scenario, what other ways do you think we can use to ensure that whatever the outputs that we get from generative models obviously comes with trade-offs, but yeah, we can basically improve the accuracy, in your opinion? Thank you.
So if you want to hear the gold answer, the best answer is do the RL reinforcement learning with verifiable reward. Okay, reinforcement learning with verifiable reward, RLVR. Okay, fine tuning using a LoRa. If you can do that on your data, you said you have a data, so you have a generative AI. Take that in your computer and do the RL fine tuning with your data using RL VR, reinforcement learning with verifiable reward, because you have a data. You said that. So that is the gold answer. Yeah, that's the best answer. Second is a like chain of thought, which you already tried it. Yeah, unfortunately, this is very new technology, and we haven't any more proven technique than that. Yeah, if you can verify it, and if you cannot verify it, maybe you yeah, that's the answer. Otherwise, if you don't have a verifiable answer, then you have a supervised training. That's the only two answer you have.
Yeah, thank you so much, Rudra.
Yeah, it's yeah, it's difficult without knowing the data sets and then also the domain. Yeah. But yeah, you can try like Rudra ji suggesting, try different technique and see which can give better. And sometimes you can combine them as well. Yeah. Okay. Any other questions?
Keshav, sir, can I say something?
Yeah, please. Yeah, Rudra ji,
yeah,
please.
okay, yeah. First of all, I'd like to thank you, SONEUK, providing this good opportunity about this, AI and those, and a very highly exceptional presentation by Rudra ji about the positive and positiveness of AI within the surroundings, how complex it is, and how we had to simplify in our developing role model, and those with the attenuation of the digital twins. And it's not my question; it's a bit more like a comment. What I can say is, in order to avoid any negative situation that can arise because of data simulation, wrong data simulations, or any negative data simulations, is again need to be reassessed within the data itself, and then we need to on that process we need to, our society need to establish a certain positive guideline and criteria that can set up within the policy, and then that only can help us to avoid those unavoidable circumstances. That's what I think in my view.
Yeah, I mean, sure. I mean, those kind of things called like filtering. We in AI, we call it the filtering technique, or like normally the red teaming, that's the last resort. So you have to, before you send an answer, you should have to pass your filter, So that's the, yeah. Unfortunately, that's the, yeah. So in AI, we don't have a like great system to tell no. We don't have a great system to stop is stop. We don't have that, and that's why we believe we need a wall model. We believe so. Yeah. So unfortunately, yeah.
Yeah, but totally agree with Rudra Koiralaji. Yeah, we need regulations, rules, guidance, and to work on ethical way on developing AI systems here. Suhaji, you have some comments or a question? Suhaji, are you there? No. Right. Okay.
Yeah, there is a one, like, the question from very similar question from the Siba in the chat, saying how can we ensure that agentic AI system controlling digital twin make autonomous decision that remains aligned with the human value and the real world safety constraint. Very similar questions, very important topic, and there are like only the three technique which I highlight. One is like forcing the reasoning, the forcing through the chain of thought using the forcing the reasoning. Second is like using reinforcement learning, RLHF, like value aligned fine tuning. Two and third is adding filtering. We unfortunately have only these three options. And how you filter it, I already told it. You can predict the confidence of your future predictions. You can get a probability. To token predict गर्छ नि हामीले जे भन्छ नि the answer दिने जुन token prediction गर्छ नि त्यसको probability हुन्छ. त्यसको probability हेर्ने कि if it is more than 60%, 50% or 40%, then you trust that answer. If the probability is low, then don't trust that. These are the like technique. I think I tell you all the gold standard of the industry or the AI community, and these are the only system we have, unfortunately. And the best guard is filtering. You have a rule of ethics. Before passing any answer, it has to pass your filter. So that is the like traditional. Okay, you couldn't even AI, just it has to pass the filter. You have to check your filter and pass. That's the only thing, unfortunately, and we don't have any better than that. Thanks. Yeah. Subhasji आउनुभएछ सर फेरि.
Subhasji, are you there? No. There is a question, I think, from Mahendra Poudel. What do you think are the main challenges of applying old model architecture to biological systems, given how complex, multi-scale, and dynamic they are?
That's very hard question. Actually, I was thinking this from the last 1 year. Very honest with you, more than 1 year, people working on AstraZeneca and Google DeepMind, but we haven't found anything. I'm sorry. I mean, the reason is this. First, we haven't able to model the to cell नै एकदमै complex रहेछ के. It's so complex, man. It has so many proteins, has so many things, and like I think digital twin kind of approach. I told you the similarity between digital twin and wall model kind of twin, wall model and digital twin, and what is the similarities and what is the difference. I think I try to highlight in the presentations to the distinction. I think better wall model, we still don't know how to apply there, unfortunately. I think the digital twin approach, which is very same, like mini wall model, and I think that should be the approach you should be taking, in my opinion. Yeah, using a like 3D geometry, like and the DeepMind को जुन चाहिँ AlphaFold जुन चाहिँ छ त्यसले चाहिँ लोकल सेल मोडल गर्छ र टी बाइन्ड त्यो बाइन्डिङहरू मोडल गर्छ लोकल चिज. आई थिङ्क त्यो नै बेस्ट अप्सन हो अहिलेको लागि, त्यो नै बेस्ट बेट हो. मेरो एन्सर चाहिँ अहिले त्यही नै फलो गर्नु जस्तो लाग्छ. थ्याङ्क यू.
Yeah, Suraj said that we cannot hear him. But if you have any questions, you can type on chat, and then we will, and I'll read for Rudraji, Suraj, if you have any questions. Yeah, real world systems are so complex, and sometimes creating their twins is really difficult. Like Rudraji, you showed NVIDIA video, one system has 7 million parameters and 7 million variables. So is it possible? We are saying that AI will will work better if we can provide environment informations in a better way, but in reality, simulating real world is really difficult. Yeah. So if you remember AI, 20 years, 30 years back, is basically expert system. So expert system is basically, you are taking very narrow scenario, try to narrow down, and then from the aspect you are trying to solve, and try to find what are the related parameters, and then only those related reasoning or related parameters, and you simulate and then solve the problem. AI actually in 1960s, tried to solve all problem, so-called generic problem solver, GPS, and it badly failed in 1970s, and then AI research basically gone down completely, and then expert systems little bit saved AI development. And then it came back in 90s, developing kind of expert systems, but solving very narrow field of narrow area. And now after Google's DeepMind, basically it re-emerged, and now again we AI researchers try to go back and then try to solve with a single model. We are trying to solve a lot of problem here. But we'll hit immediately, because of the hardware system, because of the complexity of data, complexity of relation between them, and then also the volume of the information and data. I don't know, Rudra, what you think?
Okay.
Will AI winter come again?
I think that's for sure. In my opinion, the LLM hype, in my opinion, I was predicting from last year, is still not happening. So I'm slightly worried why not happening. But the LLM, sorry, the foundation models hype will be go down for sure. There's no way. And if you trust me, my gut feeling is saying the LLM will take you to some point, but it will not take you the intelligence systems we carve for, the adaptive, the creative, and the kind of you saying like modeling the real world problems. I think we are far off. But the kind of problem you suggesting, there is a new approach. I'm sure if you are following or not, this is called physics informed machine learning. Okay, so the physics informed machine learning, what you do is in a digital twin, you can do these things. The kind of thing you can model in a digital twin, you model as a digital twin. And there are few things that's my hand is different directions. There are a few things you cannot model, right? And these things you use a function like a neural network to estimate that parameter. And you can use the output of the both of the systems, which you can model it and which you cannot model it, and together you can have a better estimations. It's kind of like in the 90s we have a noise estimation problem. You have a data, then you add a noise estimation, or using a noise you make your model more robust. You can use that kind of approach. So to conclude, I agree with you, everything cannot be modeled, and the things which cannot be modeled you can use like physics informed machine learning kind of approach. Then the approach is model what you can model and use a neural network function which you cannot model, and together you model your final questions. And that's how you can be more accurate. And if you Google it, there are very fantastic tutorial from University of Washington, and that guy is very famous. Everybody knows, in the black, he's transparent, the guy, and it's called physics information learning. He has a tutorial on the mini workshop. Is a very neat and clean, and that's the best approach available right now in the community.
Okay, thank you. There is a question from EMR Giri. Right, my question is, some social media platforms are driven by revenue-based systems, as per Rudra sir, and they are started shaping the collective mind of society in recent times. How could an old model help people like those in Nepal who have limited access to the informations develop wisdom within their society? Yeah, very similar questions.
भेरी हार्ड. अहिले मेरो आमाकै कुरा गरौँ न होइन. मेरो आमाले आएर भन्नुहुन्छ कि आज यस्तो भछ नि भन्नुहुन्छ कि अब त्यो न्युज 1 वर्ष पुरानो हुन्छ. Forget about that very complex thing, very simple thing. एकदमै गाह्रो छ. लाइक द बेस्ट, बट हामीले गाह्रो छ मात्र अभोइड गरेर त भएन होइन. त्यही भएर वर्ल्ड मोडल हुनुपर्छ भनेको त त्यहाँ त गभर्मेन्टको मोडल पनि हुन्छ नि त नि वर्ल्ड मोडल भनेको त रुल हुन्छ रेगुलेसन हुन्छ तपाईँको मोडल नै त्यसरी टिच गरिन्छ कि तपाईँको मोडलले सुन्नुहोस् है वर्ल्ड मोडल भनेको नि तपाईँको क्वेसन दिएर एन्सर दिन टिच गरिँदैन कि यस्तो यस्तो भयो भने के हुन्छ भनेर प्रिडिक्ट गरिन्छ कि त्यसले अनि बल्ल रुल लर्न गर्छ कि अनि त्यो हो भने त्यसले मिनिमाइज गर्छ एक ठिक छ तर द्याट इज भेरी फार अफ सेकेन्ड भनेको के छ भने कि तपाईँको रियली अलि इमिडिएटली रोक्ने गभर्मेन्ट रेगुलेसन बाहेक केही अप्सनै छैन यिनीहरूलाई रोक्नको लागि गभर्मेन्टको रेगुलेसन बाहेक आइ एम सो सरी टु से द्याट दे विल फाइन्ड अ चिटिङ दे विल फाइन्ड अ चिटिङ एन्ड त्यही नै हो दुइटा नै एन्सर हो एउटा एन्सर भनेको द वर्ल्ड मोडल आई टोल यु हाउ क्यान हेल्प इन द फ्युचर बट द राइट नाउ इज द रेगुलेसन इज द ओन्ली वे टु डु द्याट एन्ड आई टेल यु माई फ्यामिली स्टोरी आई एम भेरी फाइन्डिङ हार्ड एन्ड मैले मम्मी मेरो आमालाई एकदम एनोइड बनाइदिइसकेको छु अहिले लाइक यति एनोइड बनाइदिइसकेको छु कि अनि पहिला न्युज आने यो कहिलेको हेर्दै त भन्नुहुन्छ बल्ल लाइक यु फोर्स इट सिमिलरली आई गिभ एक्जाम्पल
Okay. Suhasji's question is here now. Right. Okay. I thoroughly enjoyed your talk because you quoted Cayman system, one which fast, intuitive, often dominates over the system 2, which is slow and analytical, leading to biased forecast. In the old model, perhaps these biased forecasts are referred to hallucinations. AI promises to reduce human bias, but we can see many of these human biases expanded by Cayman are equally applicable to the old model. So my question is, what extent are old model, digital twins, and agentic AI engineers working together with psychologists and behavioral economists? If not, would this be a missed opportunity?
Exactly. That's what we're doing. Exactly. I mean, I'm a cognitive science. I read a brain science, cognitive science, and that's exactly we're doing a world model. I haven't told one thing, the detail. In a world model, तपाईँले action imagine गरेर you can take many action in the future without taking the action in the real world. Right? So exactly like world model ले तपाईले भनेको कुराले exactly integrate गर्न सक्छ. Like you can take the future actions in the world, that is a long-term planning. You can take the without imaginations, that is a short-term planning. किनकि तपाईले त given actions and given a state, you can imagine what will happen next. भनेपछि what will happen next त तपाईको फ्युचर त तपाईसँग आइसक्यो त के हुन्छ भनेर तपाईसँग त फ्युचर आइसकेपछि त यो फ्युचरमा के बेस्ट एक्सन हुन्छ त हामीले पोलिसीले प्रिडिक्ट गर्न सकिहाल्छन् हामीसँग त पोलिसी छ हाम्रो 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 नियम कानुन छ पोलिसीले प्रिडिक्ट गरिहाल्छ त्यसलाई अनि त्यसपछि तपाईँ इमेजिन गर्न सक्नुहुन्छ तपाईँको त प्लानिङ चाहिँ त्यो भयो हजुरको चाहिँ सर्ट आई मिन यो सरी आई स्पिक टु मच नेपाली आई डोन्ट नो इफ दे आर एनी नन इंग्लिश स्पिकिङ and then you can really take the local actions directly too. And the kind of filtering I told you, even though you cannot apply to those filtering, it is easy to apply in the action selection mechanism. In the action selection mechanism, applying a filter is so easy than like injecting these templates to the model. So if you plan too many, means you're taking the too many actions. When you have a more actions and a more filter, the filter will be go better and better. बुझ्नु भयो नि? What I'm trying to say is, in imagination, you have a many state, many actions. Even if you cannot filter in one actions, having take many actions in the futures, you can filter better. So that will help you follow the norm. And I think I think that you exactly Subhasji, you exactly like telling what exactly we aim for, what we exactly dream for, and that is the motivations. Thank you. Actually, thank you.
Okay.
And I think I tell you how that happens, and yeah.
Okay. Right. I'll take one more questions, and then probably we need to stop here. There is a question now. How can Nepal ensure data sovereignty for its digital twins and old model, which requires massive computational resources and are often hosted by global cloud provider, to prevent digital colonizations and retain national control over strategic data? So this is from Neeraj.
हजुरलाई म ठाडो एन्सर दिन्छु मलाई होला चिन्दिन आइ एम सो सरी चिन्दिन आइ एम रियली सरी हैन भेरी बटम अफ माई हार्ट आई रेस्पेक्ट यु मैले भनेको मैले नेपालका ठुला ठुला दुईटा अर्गनाइजेसन्स नेपालको गभर्मेन्टलाई तिमीहरूलाई च्याट जिपिटी बनाओ तिमीले त्यहाँ 4वटा मात्रै इन्जिनियर हायर गर्यो म सबै म आई क्यान टेल यु लाइक आई क्यान tell you how can you implement because I told them I know how to implement ChatGPT 0 to 1 you do it my cost is free because I work in research wing so I can collaborate with anybody in the world as long as this is not a non-profitable if it is a government I can convince my company do it and I spend lots of time to talking अब गर्दैन त के गर्ने हो तर विश्वास गर्नुहोस् नेपालले च्याट जिपिटी बनाउन मेरो विचारमा अहिलेको जमानामा 6-7 करोड 10 करोड भन्दा माथि चाहिँदैन एउटा मेरो विचारमा 10 करोडमा चाहिँ च्याट जिपिटी बनाउन सकिन्छ जस्तो लाग्छ नेपाली च्याट जिपिटी नै आफै नै क्रिएट गर्न सकिन्छ जस्तो लाग्छ मलाई सो वी हेभ अ लट्स अफ नेप्लिज वी क्यान डु द्याट एन्ड तपाईँ हामी जस्तो इन्जिनियरले कन्भिन्स गर्नु पर्यो तपाईँले उठाएको प्रब्लम एकदम प्रब्लम हो नेपालको मात्रै प्रब्लम न आई क्यान टेल यु वान थिङ लाइक जापान बिकज आई वर्क इन जापानिज कम्पनी सो जापानिज इज वरिड अबाउट सेन्डिङ द डेटा टु द लाइक क्यालिफोर्निया फर स्योर is a non-hidden, you know. So probably the government data they doing on the local chat GPT, you know. मैले local chat GPT किन भन्छ नि chat GPT सबैले बुझ्छन् त्यही भएर chat GPT भनेर आएको छु तर so they have a local replica of that model. So Nepal should do that. Nepal should be using the open source. Nepal should be using the open source foundation model. Download it, fine tune it. If you don't know, I'm happy to help a weekend. Just do it. You guys are there. I think you guys are there in Nepal or somewhere, and or together we need to convince Nepalese government to do this. Or if the Nepal government don't have a fund, I think together we have to generate that fund. Maybe 10 crore is not a big deal if you really want to do this for other nations, you know, and we can do this. Yeah, I'm sorry. I mean, yeah, that's a bad thing to do, a bad thing happening, and we can do this. We have a manpower to do this. Thank you.
Okay, thank you, Rudraji. Actually, you know, a lot of discussion happened here. Within SONEUK, we have a lot of expertise around to help and work together for Nepal and also in our community here as well. There's a lot of opportunity as you seen, you know, it's still very developing area. There's a lot of challenges like Rudraji mentioned, you know, many challenges of ethics, challenges of you know, biases, challenges of you know, even coming accurate model or you know, unbiased model and so on. So yeah, lot of things to do. So there is a lot of you know, thank you message for you, Rudraji.
Thank you.
And there are few questions as well. What I will do, you know, it's just over 2 hours. I think we should. I like to close or give to Sud sir, back to Sud sir now. And any comments here, maybe we can look at it and then discuss that offline. So thank you very much for your interest. And a lot of people joined together today and a great discussion. And Soji, thank you very much for organizing this. I really appreciate. And I learned a lot of things, and I believe many of you I have learned from this session as well. Okay, thank you.
मैले सुभाषजीले एकदम यस्तो इन्ट्रेस्टिङ क्वेसन गर्नुभयो लास्टमा हैन म यसलाई आन्सर गर्छु है लाइक थ्यांक यू सो मच सुभाषजी हैन अनि फर्स्ट अफ अल आई वान्ट लाइक टु लाइक रियली ग्र्याटिट्युड यु नो सच अ डेप्थ क्वेसन्स एन्ड आई हेभ टु एप्रिसिएट द्याट एन्ड यस द स्कुनेस इन द डेटा इज देयर and that was the reasons why right now people like me working on a technique which मैले एकजना भाइलाई भनेको थिएँ reinforcement learning with the verifiable reward, you know. तपाईले जुन खालको टेक्निकल क्वेसन गर्नु भएको छ I'm pretty sure you know this, or otherwise if you Google it you just know this that's what we're trying to do right now. So you have a wall model, तपाईले भनेको डेटाको skewness त्यसमा हुन्छ for sure. So on top of that, we want to fine tune it using the verifiable reward. Verifiable reward भनेको के भने कि हामीले त्यो सिस्टमलाई हाम्रो इथिक्स अनुसारको हाम्रो त रुल त लेख्न सकिन्छ नि 100-200 वटा रुल चाहिँ छ नि त्यो इथिक्स रुल अनुसारले आफूलाई सेल्फ इम्प्रुभमेन्ट गर्ने टेक्निकमा म लगायत हामी जस्ता धेरै साइन्टिस्टहरु काम गरिरहेका छौं. I hope we will have some model, probably even from my lab, probably I as an author, hopefully in a like couple of months. I'm not saying we're solving the problem, but I can show you the direction. Probably we can mitigate such issues. Thank you. Thank you.
Thank you. So, sir,
Yes.
over to you now.
Thank you to both of you. What an intense, session. My God, when we set up this session, I got many calls from many people. If you remember, SONEUK, Nepal Engineers Association has prioritized these sessions. Maybe the time lag and other things would have been the issues, but it was very, very appreciated all around. The AI session in AI, digital twins, presented by the AI expert, moderated by the AI professor. So what else can we expect? So thank you so much. And once again, it has been very, very informative, very, very educating, and very, very engaging session. I appreciate all the participants, their patience, their time, their questions, and engagement. I can see many, list of, many, nearly 6-7 professors attending the sessions. We have the physics scientists from Imperial attending the sessions. We have Associate Commissioner of New York Development Authority Corporations, whom I met in New York. He was also attending the full session. So, and the questions and all these people are very, very appreciated. Thank you so much. I just, assure all our SONEUK member and the people listening to this webinar that we'll continue efforts to bring more and more experts to have a such similar engaging session in future. Once again, from the bottom of the heart, thank you, Dr. Rudra Poudel, for he's our vice chairperson as well. Very, very energetic, very, very, helpful. The way he performed during our last conference is amazing. Hats up to you and all your support. And our, Professor Keshav Dahal. Thank you so much, sir, for moderating in such a knowledgeable way. Your knowledge was thoroughly, coming across to us. Thank you, both of you. And what an audience, my God. Especially Professor Subhash, sir, who has not been able to talk due to technical reason, but his question was very, very intensive. So by the way, he has mentioned that he's non-engineer, and that's true. So, but his questions was above, the all level. So thank you.
My colleague cannot answer. My colleague, sorry, my boss cannot. He's probably sorry. I shouldn't say these things. So probably my boss cannot question that. Thank you.
So thank you all of you for your the very, very engaging participations. Thank you. I don't have any other word than the thank you. We learned a lot.
Thank you.
And then we'll have similar sessions. There's so much to take home from these sessions. We are even excited to have similar sessions in future. Any of the questions, if they are not answered, Dr. Rudra Poudel, Dr. Professor Keshav Dahal, and you can approach any of them or through me or directly. So SONEUK will always be there to help you in many aspects. Thank you, sir. Thank you once again.
Thank you.
Thank you.
Thank you.
Yeah, we'll bring this meeting to close. Thank you.
Thank you.
Bye, sir.
Bye.